All right, in this video, we're going to take a look at solving trig equations and giving all solutions. And I'm going to show you a couple of things to keep in mind. And it's really a combination often of your algebra and your trigonometry. So the first example here is cosine squared plus 2 cosine x equals -1. And I first want to just draw your attention to the cosine squared of x. Remember that notation means the same thing as cosine x quantity squared. And just to kind of scaffold it a little bit for you, I'm going to just replace the cosine x with a letter. In fact, why don't we just kind of abbreviate and say that c is going to stand in for cosine of x. So for the moment, I'm going to actually rewrite this equation as c squared plus 2c equals -1. So again, I'm replacing the cosine x with a letter. And I'm doing this because it's going to remind you that the first thing you want to do is the algebra, right? You want to solve this equation as though you were just doing the algebra and not the trigonometry. So I add 1 to both sides to get this, and we factor. So we have a quadratic and we factor, and I believe this would be c plus 1 times c plus 1. And all that means is that c would have to equal -1. Okay, now if it was algebra, you'd be done, but this is a trigonometric equation, so we've got to bring in now the trigonometry. So let's go back now and remind ourselves that the c stood for cosine x. So I'm going to rewrite this now as cosine of x equals -1. Now, there are many ways to think about solving this equation. I think the best way is to remember that cosine is the x-coordinate of a point on the unit circle. So on the unit circle, we want to know what angle would I rotate to in order to just put that so we know it's the unit circle. What angle would I rotate to give an x-coordinate of -1? Well, it would be this angle, which happens to be 180. And I'm going to use radians here, so that means x equals pi. Okay, now we want all solutions. And of course, we could just rotate in either direction another 2 pi and land in the same spot. So what I want to do to give all solutions is add multiples of 2 pi. So I'm going to put plus 2 pi n, but I need to ensure n is an integer. So the notation you use is this. Okay, so we started with the algebra and ended with the trigonometry, and I gave all solutions because cosine is a periodic function, which means adding and subtracting multiples of 2 pi produce coterminal angles, all of which are solutions. This example 4 here is going to be a little tricky, so I'm going to show you a little couple things to be aware of. So I've got tangent of x times cosine of x equals 1. So how do I solve that? Well, we could replace the tangent with t and the cosine with c, like we did above. But those are two different variables, and it's not immediately obvious what I would do after that, right? Two numbers multiplied to 1, well, there are infinite combinations you could get there. So we might try an identity. So we might notice that tangent of x is equal to sine of x over cosine of x. So I want to rewrite this equation as sine of x over cosine of x. Now, you're going to notice something neat and convenient, but then I gotta kind of caution you after. So you probably see this and you say, well, this is great. The cosines divide. And now I can write sine of x equals 1. Okay. So to solve this equation, let's go back to the trigonometry, right? I'm going to scroll down a little bit. So sine is the y-coordinate of a point on the unit circle. So if the unit circle is this drawing, then I would notice that the y-coordinate is 1 when I rotate this angle. But that angle is pi over 2. So I might say, well, x equals pi over 2 plus, of course, multiples of 2 pi n, or multiples of 2 pi, rather. Now, at this point, you might think you're done and that you solve this equation. But in dividing or in crossing off those cosines, you actually you transform this original equation into one that's actually different. So what you need to do is you need to check to see that this actually works. So I'm just going to do a check down here, and you're going to see that it's not going to work. So let's see. So I'm going to plug in pi, for instance. We can't plug in all the answers. I'm going to plug in pi. So tangent of pi, pi over 2. Tangent of pi over 2 times cosine of pi over 2 is equal to 1. Does that work? No, not quite, because tangent of pi over 2, that's undefined, right? Rotate pi over 2 and just think of the slope of the line through, right? When you the slope of the line through the origin when you rotate pi over 2 is going to give you tangent of pi over 2. This is undefined, so it's not going to work. Okay, and cosine of pi over 2 doesn't matter what it is; it's irrelevant, but it happens to be 0. But in any case, this didn't work. So the pi over 2 and all angles coterminal with pi over 2 are not going to work in this case. So we were too quick to jump to the conclusion that we solve this equation. So the answer is that there is no solution to this equation. No solution. If you graphed tan x, cosine x, and 1 as two equations into Desmos, you would notice that it looks like they intersect, but at the moments they intersect, the value of the left function would not be defined. I'm going to call this way 1. I just want to show you, you could have gone about this a different way, but you'll end up in the same spot. So maybe you decided to do this equation differently. Maybe you said, look, I'm going to avoid dividing if I can. So I'm still going to use the identity, sine of x over cosine of x times cosine of x equals 1. But I'm not going to divide. I'm not going to cancel. I'm going to try my best to avoid that. So this is sine of x cosine of x over cosine of x. And I'm going to rewrite 1 as cosine of x over cosine of x. Now, I've turned this into basically a rational equation. The denominators are the same, which means I can set the numerators equal. So now I see that sine of x times cosine of x is equal to cosine of x. Now again, don't divide both sides by cosine of x. Instead, do this. Subtract cosine of x from both sides. So I've got sine of x times cosine of x minus cosine of x is equal to 0. And then we factor. So I've got sine of x times, minus 1 and a cosine of x factored out, right? Because there's a cosine of x in both terms. All right, so now I've got two equations, and let's solve them each. So this left piece implies that sine of x equals 1. This right piece implies that cosine of x equals 0. But sine of x equaling to 1 is going to yield the same thing I have up here, right? Pi over 2 plus multiples of 2 pi. Cosine of x equaling 0, so again, if we look at my circle up here, cosine of x is the x-coordinate of a point on the unit circle. Well, when is the x-coordinate 0? It's 0 here. It's also 0 here, which gives the angle pi over 2. We already have that over here, but also 3 pi over 2. Okay, so again, you do all this work and you think you're done. But we check, right? We go check the original equation. The original equation was tangent of x times cosine of x equals 1. Again, we're going to run into a problem because tangent of, well, we already tried pi over 2, and that didn't work. But the tangent of 3 pi over 2, cosine of 3 pi over 2, and then obviously all angles coterminal with that, are not going to work either because rotating 3 pi over 2, right, brings you down there, and then the line through the origin through that point also has an undefined slope. Okay, so again, that doesn't work, neither does that, and we're left with the same conclusion, that there is no solution. So trigonometric identities, solving trig equations involves often a little algebra, like I did here. It involves some factoring and the trigonometry, but on certain occasions, you've got to be a little careful because you could get extraneous solutions as we did here. So this has no solution.